Okay, hello, my name is Ardi and we are going to solve problem number 19 from chapter 4 of Hayt's book. For the circuit shown in figure 4.49, determine a numerical value for the voltage labeled V1. So V1 is here, but we have a problem here. If we want to use nodal analysis, we have this voltage source between two nodes here. What is the problem? So we cannot find the current that passed through this current source. So how to deal with that? Let's just assume that this voltage source is a very big node, that we call it a supernode. Okay, let's label this as our supernode. And as usual, maybe let's label this as V2, this node here, this specific node. So let's do KCL at supernode. I'll have KCL at supernode. But first, let's assume the direction of the current here. Just follow this 3 ampere volt current source, and this may be going to the right, this may be going down, and this might be going down, and just follow it. Okay. And remember, KCL said that the sum of the currents that goes in is equal to the sum of the currents that goes out. Maybe for a better visualization, I will also include this one. So yeah, this is still not V1, right? And okay, now the current that goes in will be from this current here to the supernode. So I will have 3, and then plus this current here that going to V2, but that is V1 minus V2 divided by 1. Yeah, I think all of the current that goes in already plug in. So now let's deal with the current that goes out. So first, let's see this one. This current is going out from the supernode, right? So I will have V1 minus V2 also divided by 1. Okay, and this current here, so I'll have plus V1 over 5. And then this current here, that will be V2 over 9. So I'll have plus V2 over 9. And then this current here, that will be 5. Okay, now let's cancel out this one and this one. So because this is canceled, that becomes 0. So what can we left with here? So I have 3 is equal to V1 over 5 plus V2 over 9 plus 5. And I think let's move 5 to the left hand side here. So I'll have V1 over 5 plus V2 over 9. That will equal to minus 2. And let's multiply both sides by 45 to get rid of the denominator. So I will get 9V1 plus 5V2, and then that will equal to minus 90. Save this as equation number 1. But we have 2 variables, but only 1 equation. We still need to do 1 more. How can we get that? Let's see at 9-volt voltage source. Remember that the difference between this node and this node is always be 9. So I will use that fact. So I'll have at 90-volt voltage source, I will have V1 minus V2. Okay, V1 minus V2, that always equal to 9. So let's have that as equation number 2. We can rewrite both of this equation in the matrix form. So from this equation, I will have 9 and 5. From this equation, I will have 1 and minus 1. Okay. And I will have V1 and V2 here. And the result vector will be, this one will here will be minus 90. And this one here will be 9. Okay, that's all. Let's plug the equation to calculator. S and 5, we only need two variables, so number 1. So I will just plug 9, 5, and minus 90. And then this one will be 1, minus 1, and then 9. Okay, I will have V1 will be minus 3.214. Okay. V1 will be minus 3.214. And the unit will be volt. And V2, what is V2? V2 will be minus 12.214. Okay, minus 12.214. And we are asked about V1, right? We are asked about V1. So V1 is this value here. Okay, that is the final answer of the question. Hopefully, I did not make any mistakes in the calculation. And thank you for watching. Bye-bye.